So we can get rid of this stuff and push it way down. So we're good with that. What'd you say?
Your friend.
We get our M30 out of there and get it out of the way. Now, what do you think that we should do next?
Agree.
Okay. Anybody think anything differently?
I'd just say do that since it's
Better the thread.
No. We'll wait to do it until last.
Don't we still need to get
or tool change?
Right. So by doing the threads next, we can save that last tool change to come in here, groove it, chamfer it, part it, and do all that at once. Okay. So what I think I'll do is I'll just do a G0, Z5, and then M01, and then call it my next tool. And
did you do a G28 after the M01?
did I?
No.
Well, I guess.
I don't know that I really want to send every axis home. Okay. So now, yeah, I did 202. So we'll do 1, 2, and 4 for the tools for this one. So I don't want to start all the way up at 1.6. That thread diameter that I'm doing, I'm going to start in the front and move to the back. So I'll start out at like 0.6. And then if you'll find in your book on page 42 of the new book, it should show you what a G76 should look like. It's going to be G76. And luckily John still has his book open, so we can use some of his numbers and some of his number finding skills. We've got to find the minor diameter of this. So G76 is going to contain X, Z, a U and a W if we wanted to, a K, and then it can also have an I in there if we want to, and then it's going to have a D. So if you're looking at page 42, anything that's got an asterisk in it is an option, and so we will want to put those things in there. John, do you know what on our half 24 thread, what's our minor diameter? No.
The minor diameter max?
Yeah. $449,002. 449. It's not a very deep thread. Yeah, that's you want
That only makes sense because there'll be 1,000.
No. It's almost 500,000. So each the thread's going to be 50,000 deep. That is right. 449. So we'll go to X of 0.449 for our diameter. We'll go back. Z is going to be minus 0.650 thousandths. We are not concerned about leaving an offset for U or Z, so the I'm sorry, for X or Z, so the U and W doesn't matter. K is the thread height and radial value. So we're going from really 0.6 minus 0.449, which is 151 thousandths. And actually, let's do this. I'm going to shrink it down just a little bit so we don't error cut. So I'm going to go ahead and change this to 0.5. So I just changed our start point. Instead of 0.6, I changed it to 0.5. And so then our K value, I'm going to take 0.5 minus 0.449. I get 51 thousandths. Divide that in half because it's radial. So I get 25.5. So K is 0.255.
Does the machine handbook tell us that as well?
What's that?
Does the machine's handbook tell us that as well?
Tell us what? The half of thread height?
Yeah.
No. I'm looking at page 42. Are you looking at page 42?
I'm on page 41.
Okay. I'm on page 42, and it says K is the thread height in a radius value.
Yeah, all mine are on 41.
Okay. So it says the same thing though. So you just got a different. You just have an older book. D is the next letter, or next value. It's going to be what you want your first pass to be. I want my first pass to be pretty heavy. It's going to be 10 thousandths. And then you have to have an F. What do you think our F is?
Feed rate.
Feed rate, yeah. So how do we figure up our feed rate?
0.003.
No. So now it has to be timed to the spindle. So we've got to go 1 divided by our threads per inch to figure out what?
1 divided by 50.
1 divided by 24. So what is that?
24.
0.0 what?
0.0416.
Yeah. Feed is going to be 0.0416. Now, we do not have to be concerned about the RPM because we're controlling the RPM in a different place. And so the spindle's synchronized with our threading, so we don't have to worry about that. Okay, so this will create our thread starting at 500, Z of 0.1, going down to 449, going back to 650 thousandths. So another way of doing the thread, I'm gonna do it and then I'm gonna erase it. You could also do a G92 and do X 0.495 and then Z minus 0.65 and F 0.0416 and then go X 0.490, X 0.485. See how you can just do single pass threads. If you wanted to take like a couple of heavy cuts and then a couple of light cuts on your part, and doing something like a G92 will help you if you really need to get that part done as fast as possible. First couple cuts can be super heavy. Last couple cuts could be a little lighter. Yeah.
Normally, we cut thread. The last ones I cut were about 130. The first cut was 50.
Yeah.
The second cut was 25.
Absolutely. Start
And
decreasing it.
10,
Yeah. And some of the cycles, Akuma's like this, and probably Haas has some that are like this too, where they have cycles that are set in there where first cut is 50%, second cut is 30%, third cut is 20%, 10%, 5%, and then maybe a free pass in there. So you can go in there and let it help you do some stuff like that. Okay, so that does first thread. When it gets done, it goes back to X of a ½ inch, Z of 0.1. Now we'll go X 0.75, Z minus 0.75. So I'm just moving up So I'm moving over to about here. I'm just going to do the exact same thing, right? It's the exact same threads per inch. So I'm really going to take and just copy this whole section here. Sorry, this should be a G0 on that X is 750, Z minus 750. So I'm going to copy this. I'm going to paste this here. But my X and Z change. So what does my Z change to? What? But it's absolute from the beginning. So 0.55 plus 0.75. 1.3. Yes. So now all we need is an X. Mikhail gave us the Z. Somebody else give us the X. John, you got the book. Why don't you tell us what the X is? Don't you wish you didn't bring the book? X.699. Okay, so that is 51 thousandths. That equals out right. So K stays the same. And I think that D can stay the same at 10 thousandths. After I'm done with that, I'll go maybe G0, X 1.6, Z 0.1, just to get my tool out of there. And then I'm going to ask you to go ahead and save it and run it in your simulator.